to find the value of I. And we are told that from the question we said we use Kirchhoff's law to find the value of I in the figure below. If we look at this figure, we can see that we have a battery source. We have a battery which has an inherent resistance of 0.4 ohms. I can decide to bring that 0.4 ohms up here in series, 0.4 ohms, so that when I combine this series combination, I will get 5.4 ohms. That is my combination. I add it to that. So that 5.4 is in series to the rest of the circuit. And then I can see that we have two loops here. We have, let me call this loop 1, and let me call that the I1 loop. I1 loop. And then we have this second loop here, loop 2. And let me call that the I2 loop. So we have the I1 loop and then the I2 loop. Let us look at this. Let us look at the above. We have that we have an arm of we have an arm there, which is this arm, which corresponds both to the I1 loop and the I2 loop. That arm there, 7 ohm resistor, corresponds to both the I1 loop and the I2 loop. You can see that it is a kind of midpoint between the two. What affects the I1 affects it, I1 loop affects it, and also I2 loop affects it. That will come into play in writing our first equation. So let us look at that. Go into solving using our Kirchhoff's voltage law or the loop law. So what are we going to do? If we look at this now, we have that we have 30 volts, and when there is a connection in series, when there's a connection in series to a voltage source, we'll have what we call a voltage drop. Would have what we call a voltage drop. So the sum of currents in this loop is equal to 30 minus, remember, voltage drop, 30 minus and the voltage drop across the 5.4 ohm resistor is based on the fact that V is equal to IR. R in this case is 5.4 and I in this case is I1. So that will be 5.4 I1. And then if we look at minus the voltage drop across the 7 ohm resistor, so if we look at that, we can see that the 7 ohm resistor for this loop corresponds to two currents, the current for I1 and the current for loop I2. So in that case, I'll put it as 7 into brackets I1, which is our main loop, minus I2, and this is equal to 0. So we can resolve that, and we have that 30 minus 5.4 I1 minus 7 I1 plus 7 I2 is equal to 0. So therefore, we can add the I1 together. We can have 30 minus 5.4 minus 7 is 12.4. 30 minus 12.4 I1 plus 7 I2 is equal to 0. This now makes it equal to, let's call this one equation 1. Then for equation 2, we have that we have from our expression there, looking at the second loop, equation 2. If we look at the loop, if we look at the second loop, we can see that like we said before, the 7 ohm resistor cuts across the two loops. So I can write that as my V2, which is my 7 ohm resistor, into bracket the current through it, which is I1 minus I2. I've taken my clockwise direction to be positive and the anti-clockwise direction to be negative. So 7 into bracket I1 minus I2 is equal to 3I2. And I can resolve that. I have that 7I1 minus 7I2 is equal to 3I2. And this means that 7I1 is equal to 7I1 is equal to 10I2. So that I1 will be equal to 10 over 7I2. Or I can say that I2 is equal to 7 over 10I1. Let me call this equation 2. So we're going to be substituting equation 2 into equation 1. To do that, we have equation 1 is equal to, we have 30 minus 12.4 I1 plus 7 into bracket 7 over 10 I1. Now, if we're going to resolve this, we would have 30 minus 12.4 I1 plus 4.9 I1. And remember, this is equal to 0. So, this gives us 30 minus 12.4 I1 plus 4.9 I1 is going to be to give us minus 12.4 I1 plus 4.9 I1 is going to give us minus 7.5 I1, and that is equal to 0. So therefore, I1 would be equal to 30 over 7.5. Therefore, that means that I1 is equal to 30 over 7.5. I think that should give us 4. So I1 is equal to 4 amps. 4 amps. I1 is equal to 4 amps. Therefore, I1 is equal to I, which is equal to 4 amps.